Well, the most important topic that we're going to really talk about here in this section is the mean value theorem, which is hence the title of the section. Okay, and hopefully y'all have already looked through this note, you've read through the notes, so as I kind of come through here, let's just make some highlights. Just reiterate that a continuous function, for a function to be continuous, it means that the value of the function evaluated at a specific point has to exist, and that the limit from the left and right as the function approaches that point has to exist, and specifically those 2 points are going to equal each other. Okay? Rolle's theorem basically says that if you have a function that's continuous over its whole entire domain, then and that it's also differentiable everywhere in the open interval a to b, then there's some point in there where the derivative eventually has to equal 0. Okay, so like I said, some note points, that means that there's at least somewhere in there that if you have a continuous function and it's differentiable everywhere, there's got to be at least a flat portion in there where your derivative is going to equal 0, so a little horizontal area in there. Okay, and the mean value theorem. Okay, I drew a graph over here on the left to kind of, hopefully y'all can make some sense of it, and what it's talking about is the fact that if f of x is a continuous function, so it's a continuous curve, like red line right there, it's all continuous curve, it's over its entire domain, let's say from a to b, and it's differentiable everywhere in a to b, then there's some point x equals c where f of b minus f of a over b minus a is equal to the derivative at c. Okay, so this next part is what I kind of wrote in there. So the slope of the chord, that's what this left part is equaling. It's talking about the slope of the line between this connecting the points A and B. So that's that blue line over there. To go from point A to point B, and we're making this chord right here. So it's saying the slope of this chord has got to equal the slope at a specific point C. Because remember, derivative finds the slope. So that's what we're saying right there. That's that purple line right there. That somewhere in there, that those two slopes are equal to each other. That the slope of the chord equals the slope at that specific derivative. And so how you can also see it is the average change is going to equal the instantaneous change. The average change from A to B is going to equal the instantaneous change at C. Okay, so going on, there's some other key points that you can read about. Obviously, if two derivatives are equal, that means two slopes are equal, and the only kind of lines that have exact equal slopes have to be parallel lines. The only difference is their y-intercept, typical what we know. So let's go to example 1 and get some work done. Okay, we have a function f of x is equal to the square root of x minus 1, specifically on the interval from 1 to 3, and we want to find the value or values of c that's going to satisfy the fact of the mean value theorem, saying that the chord that's connecting from 1 to 3 is going to equal the derivative somewhere between 1 and 3. We specifically want to know where in that interval are we going to get it equal to each other. Okay, so let's just find what the formula says. Let's find f of b, so b, or a being 1 and b being 3. So if we go f of 3 minus f of 1 all over 3 minus 1, and that should equal the derivative evaluated at c. Okay, well, f of 3 is the square root of 3 minus 1, which is the square root of 2, minus the square root of 1 minus 1, so the square root of 0 is 0, all over 2. Okay, and let's go let's find the derivative. Okay, f prime of x. Well, f of x is going to equal x minus 1 to the 1/2. So f prime of x is going to be 1/2 x minus 1 to the negative 1/2. Okay, so let's fill that in over here on this right side. So it should equal 1/2 times x minus 1 to the negative 1/2. And then we're going to solve this for x, or if you want me to, what I can do is actually, instead of using an x, let's just use a c. And then that way, so it's like the derivative evaluated at c, we just plug c into there, and then that way it comes out with c equals this, and it answers our question. All right, so square root of 2 over 2 is going to equal to 1 over 2 times, and if you want to look at this, put it back, I'm going to put this in denominator so it makes that exponent positive, square root of c minus 1. So let's just keep solving this for c. If we multiply everything through by 2, then you get the square root of 2 is equal to 1 over the square root of c minus 1. Let's square both sides. So square root of 2 squared is 2. 1 squared is 1, and then c minus 1. Multiply both sides by c minus 1 so we can clear this out. And we get 2c minus 2 is equal to 1, or c is equal to 3/2. So at 3/2 specifically, which is in that interval, 3/2 is 1.5. So at 3/2 or 1.5, then that means the derivative evaluated, or the slope at 3/2 on the graph specifically, is going to equal the slope going from 1 to 3. Okay, example 2. In this example, they just want us to basically do what we did for example 1. They want us to determine if the following functions satisfy the mean value theorem. So what we've got to do is test to see, does f of b minus f of a over b minus a equal the derivative at some point c that's in between a and b. Okay, so it's really checking out to see, does c fall between a and b? Like above, 3/2 fell in that interval from 1 to 3, so we just need to check for that. So here's part A. Okay, so let's write out here, let's go ahead and do the derivative right here. The derivative is going to be 4/5 x to the negative 1/5. B is 1, A is 0, so there's A and B. Okay, so let's finish this out. So f of 1 minus f of 0 over 1 minus 0 needs to equal the derivative evaluated at c. Okay, so f of 1, 1 to the 4/5 is 1, 0 to the 4/5 is 0, so 1 over 1 is going to equal 4/5 c to the negative 1/5. Okay, 1, or by the time we clear this out, we can say 4 is equal to c to the negative 1/5. Okay, or to get c by itself, why don't we raise both sides to the negative 5th power? Okay, so this is saying 4 to the negative 5th is equal to c. And if we look at that in our calculators, 4 to the negative 5th is going to be a very, very, very small number, because it's, it's 1 over 4 to the 5th, but it's positive. It's going to be between 0 and 1, so what this is saying is, since c does fall in that interval, then yes, it does satisfy the mean value theorem. So I would say, if you want to write it out, maybe f of x is equal to x to the 4/5 from 0 to 1 satisfies the mean value theorem. Oops. I was looking at that and I was thinking, if that was MVF, I don't know if y'all watch Man vs. Food on the Food Network, or I think it's on the Travel Channel or TLC or something like that, but I'm used to watching MVF, but it's the mean value theorem. Okay, so now I'm going to erase this for a second. Let's come back and look at it for part B. Well, to solve this problem, what I would do is, since it's a piecewise function, let's just focus on each piece individually. The first one is just 2x minus 3 from 0 to 2, so there's a to b. And the next one is that quadratic from a to b. Okay, so let's just focus on the first part, and let's do the theorem. So looks like f of 2 minus f of 0 over 2 minus 0, which is 2, should equal the derivative of 2x minus 3, which is just 2. Okay, so f of 2 is 2 times 2 minus 3, so 4 minus 3 is 1, minus f of 0, which is negative 3, all over 2. So 1 plus 3 is 4 divided by 2, so 2 equals 2. And this is good. We needed this to happen, especially since the derivative was going to equal 2 no matter what. What it's saying is then the instantaneous slope, no matter where you are on that graph, is 2, which makes sense. It's in y equals mx plus b. Well, what's the slope? It's always 2. And saying is that whether you look at a chord connecting two dots or you look at an instantaneous point anywhere along the graph, the slopes are always going to be equal, which should always happen, especially when you're looking at a line. So far, the mean value theorem definitely checks out for the first part of this piecewise function. Let's go to the second part then. So if we do here, f of 3 minus f of 2 all over 3 minus 2, which is 1, should equal the derivative. So 6 minus, instead of saying 2x, I'm going to say 2c. Okay? So f of 3 looks like 18 minus 9 minus 7 minus f of 2, which is 12 minus 4 minus 7, should equal 6 minus 2c. And on that left side, we'll get all reduces down to 1 is equal to 6 minus 2c. And then moving 6 over, 1 minus 6 is negative 5 is equal to negative 2c. So c is equal to 5 halves, or 2.5. So let's check. Is 2.5 in this interval? It is, so it checks out. So in either case, then yes, that this piecewise function, so f of x satisfies the mean value theorem. Let's move on to example 3.